Hi there everyone, and welcome to the test review. So if you're listening to this means that I was able to get it out for you so that you can go over your test review worksheet that you were given. This is the 1.6 through 1.10 and 1.1 test review. So I'm just going to go through each of the questions, and you can scan through on the video and look at the answers and see which ones you got wrong. And then you want to listen to the explanation only for the ones that you got wrong. Or you can listen to all of them. It's up to you. So let's go ahead and get started. All right, so on this page, this is just a copy of what your worksheet should look like. If you do not have everything updated for question 3, you want to update that now. It should be 1.22 times 10 to the 13th, 1.12 times 10 to the 13th, 3.15 times 10 to the 8th, 1.06 times 10 to the 7th. So that's what number 3 should look like, but we are going to go from here. So the first thing we're going to look at is number 1. You have 4.115 times 10 to the 5th power. Notice I put the 5th power in yellow. So you're going to rewrite the 4.115, and with that 5, you're going to go over 5 spaces to the right. You're going 5 spaces to the right because it's positive. 1, 2, 3, 4, 5. And then you're going to add the zeros for space holders where you've had to loop under. So you've got 0, 0. Now when you rewrite, you're going to rewrite in, remember it's asking you to rewrite in standard form. So you want to make sure that you start by writing on the far right side. So notice I just wrote 0, 0, and then 5. All I'm doing is copying the numbers right here. And so once you write the 0, 0, 5, you're going to keep going after the comma, and you get 411,500. So that is how we do that one. The next one we've got is 3.85 times 10 to the negative 4th power. So we're going to set it up the same way, except now I'm going to kind of move my 3.85 to the right a little bit because I'm going to anticipate that I'm going to move this decimal to the left because it's a negative exponent. So we're going to move it our 4 spaces back to the left. Then we need to add those zeros for placeholders. And we get 0.000385. Notice that leading 0, it doesn't change the value of anything. It's basically just there for formatting. So let's go ahead and move right along. All right, this is that problem that we were looking at for number 3. So the very first step is the one that I've done here for you in orange. It says least to greatest. Make sure that you always read that problem to make sure that you're actually doing least to greatest or greatest to least. And now you're going to list the years. So the first thing you look at is the exponent. Since we're doing least to greatest, notice I underlined the 7. That's because 7 is the smallest exponent. So regardless of what these numbers here are in the front, the 7 is still going to be the smallest number because that means you're going to have 7 more places to the right. So that means that it's going to be the smallest value. So that means year 4 was the smallest. Then we look at the 8 on the next one up, and that was actually 3.15 times 10 to the 8. And again, regardless of what those numbers are in front, it doesn't matter. They have to be, you have to look at the exponents first. So then we're going to go on and compare the last two. And as you can tell, you still have to the 13th power for both of these. So now you have to look at the front number. You only have to look at the front number if you are, if you have exponents that are the same in this case. So look at the front number, and you want to compare them starting with the ones. So 1 and 1 were the same. 2 and 1 are not the same. So since 1 is less than 2, that's why year 2 goes next. Whoops, whoops, whoops. Hold on one second. Let's go back here. There we go. Sorry about that. So year 2 will go next, and then year 1 will go last because it is the greatest number. So that's it for that problem. Now we can go. All right. So I just scribble out the other problems so that we're not distracted by it. So the first thing we're going to do here when we look at this problem is we're going to use the associative and the commutative property to get those decimals together again, the 5.8 times 6.4. And then we can't forget, pardon me, we can't forget about the exponents. So that's our next step. Notice we get 10 to the 5th and 10 to the 2nd. Now, I should have said something before we started. When you look at this problem, before you even really start the problem, you needed to make sure that you were doing multiplication. So this is multiplication because there are no addition or subtraction signs in between right there. So we're doing multiplication. That's why we use the commutative property and the associative property to get them together. So now, as you can tell, I took the 5.8 times 6.4 and I got 37.12. Move the decimal out one space for each of those numbers, 5.8 and then also for 6.4. And then in the answer, we'll move it back in two spaces for 37.12. We're not finished with the problem yet. We're going to put the 37.12 right there. And now we're going to work with the exponents. So remember, when you're multiplying exponents, you don't actually multiply the exponent, because remember, that's reserved for a power to a power. So when you're multiplying exponents, you add the exponents together. So this should be 10 to the 5 plus 2. I do want to see you showing that 5 plus 2, because when you get negative exponents involved and such, it makes it more difficult, and that's where those small errors come into play. So now we're going to go ahead and simplify further with 37.12 times 10 to the 7th. But if you notice, you want to look there at that scientific notation that I just underlined for you. Please make sure that your answers are in scientific notation. You can tell here that ours is not, because the decimal is past the 7. So that means our number right now is 37 and some change. We need that number to be between 1 and 10, essentially. So 1 and 9.99999. So anyhow, we're going to have to, X marks the spot where the decimal needs to go for that pink X right there. So what we want to look at is, before we've moved the decimal, was that number greater than 1 or less than 1? And it was greater than 1. So you'll notice just next to the exponent of 7, I added 1. So you would need to add 1 as well, because the number before we moved the decimal was greater than 1. So now we're going to move the decimal, 3.712 times 10 to the 8th power, and that's our final answer. The next problem we have is division. Remember, that fraction bar that you see there means division. So we're going to first set it up as a division problem, where we're going to separate out the 2.052 and 5.4. We're going to separate those from the exponents. So you can see that I've done that here. Then we're going to deal with the exponents. The exponents, when you divide them, the opposite of adding them, we're going to subtract. Because we're dividing, it's going to be 10 to the 7th minus 4. So sometimes you're going to end up with a negative exponent there, and that's okay. It just depends on what the problem is. So now we just do the division for the 2.052 divided by 5.4. That gives us 0.38. And now we're going to deal with the exponents, which should be times 10 to the 3rd, because 7 minus 4 is 3. So now this still isn't in scientific notation. Notice I put it in blue and I said question mark. Is this in scientific notation? It is not. So we need to do that. So we're going to, X marks the spot between the 3 and the 8. So now our new answer should be 3.8. But if you look, that number before we moved the decimal was less than 1. So that's why you see that blue minus 1 next to the 3 pink exponent. We're going to do 3 minus 1. So now you're going to see it as 3.8 times 10 to the 2nd power, because 3 minus 1 is 2. So make sure that you notice you can't just move the decimal from before the 3 to after the 3 without changing the exponent. And then also you want to notice how you change it. Did you add 1 or subtract 1? Those are all very important, and they mean the difference between completely right or completely wrong. All right, so for this section on finding the root, square roots, cube roots, there really isn't a ton of work to go with this. These are those numbers that you were supposed to memorize, the square roots and the cubes, the perfect squares, perfect cubes. So I'm just kind of showing you that the square root of 16 means what number times what number equals 16, and you should know that that is 4. Then we have the cube root of 729. So we're saying what number times what number times what number equals 729. So that number turns out to be 9 times 9, which is 81, times 9, which is 729. So the answer for the cube root of the cube root of 729 is 9. Now we're going to look at number 7. Number 7's special because it's got that negative sign underneath the radical. So we need to ask ourselves, can we have a negative number times a negative number and equal a negative 289? Can that happen, folks? No, because when you have a negative times a negative, it will always equal a positive. So because of that, negative times negative must equal the positive. That is a no real solution or no real square root. You want to go ahead and make sure that you put that as your answer. Either one would be acceptable. So remember, that is for square roots. You cannot have a negative under the radical. It can be outside the radical, but it cannot be under. All right, solve each equation. So we did a lot of these problems. You want to look at this as x squared equals 49. And remember, in all of the teaching, I said, how do you undo squaring? How do you undo squaring? Because remember, solving equations is all about undoing. So since we need to get x by itself, to undo squaring, you're going to have to square root both sides. So when we square root x squared, we're left with just x. And when we square root 49, we're left with 7. So the answer for this problem is x equals 7. So for this problem, it says a new restaurant has ordered 64 tables for its outdoor patio. If the manager arranges the tables in a square formation, how many will be in each row? So you want to make sure that you're annotating the problems. To annotate the problems means that you are underlining the important pieces of information that you are potentially going to use in the problem. So if you'll notice, I underlined 64 tables. Most of you probably would already know to underline that because it has a number in it. But some of you may not have underlined the word square. The word square in these types of problems with squares and square rooting is essential. If this is not a square, then you cannot apply the square root and squaring philosophies. So it is a square, and then it says how many rows will be in each. Even as a very seasoned math teacher, I always draw myself a picture because I need to visually see what's happening in the problem. So I made this a square. I know there's going to be a total of 64 tables in all, and each side length is going to be the number of tables on each row. So now we're going to look. Basically, this looks just like those area of a square problems that we've been working on. So I'm going to set it up as area equals side squared. Then we have 64 tables being the area equals side squared. And now we're going to square root both sides just like we did in that previous problem so that we can find out that S by itself, meaning one side length, is going to be 8. So that means there are 8 tables. Each row will have 8 tables. So now you know, 8 tables on one side, 8 tables on the other, and then that will give you that 64 tables that you are looking for. So now we're looking at number 10, the formula for the perimeter of a square. Remember I told you they were going to give you this formula where it says P equals 4S. So you can use that formula, but really the formula that you need to be remembering for all of these square problems is A equals side squared. Now they tell you about the formula for the perimeter of a square because they don't want you to forget that you're going to have to add them up at the end. I prefer to have you look at it as adding, but that's just my preference. So we're going to set this problem up exactly the way that we did number 9. And we put the area in the middle. We have side lengths on the side. And now we're going to use the formula, area equals side squared. Now we're going to fill in 81 because they told us that the area is 81. And then side squared because we're still trying to solve for the side length. So now we have area, we're going to square root both sides. And we get that the side length for one side is going to be 9. This is not the end of this problem. Please be sure that you make a note to yourself when you're working on perimeter problems to put a little star by it, maybe so that you can remember that it's a 2-step process here. So now you're going to find the perimeter. So the perimeter is going to be side plus side plus side plus side, or it's going to be perimeter equals 4 times the side length. Either one works out just fine. In this case, perimeter equals 4S is 4 times 9. Notice I labeled each side with 9, and 4 times 9 gives you 36. So make sure that when you finish, you see that your answer should be 36, there we go, 36 feet. Not square feet, because that would be talking about area. We're talking about perimeter or side length. So perimeter equals 36 feet. And, all right, so let's take a look at this one. Do not be intimidated by these problems. These problems look intimidating, but they're really not. So it says the radius of a cylinder with volume V and height 20 centimeters is approximately the square root of V divided by 30. If a can that is 20 centimeters, so notice that the 20 centimeters is the same in both. If a can that is 20 centimeters has a volume of 1,200 cubic centimeters, so now they've actually given you the volume, then estimate its radius. So you did have to kind of go back for a second and read that problem just so that you could see that the radius, what they're actually showing you here is that R equals the square root of the volume divided by 30. So I did have to go back in and kind of identify that we were solving for radius. And that's actually a really good trick because when you're trying to identify what each letter means, then you're starting to realize more and more about the problem, about what the parts are that you're solving for. So in this problem, we're going to be solving for the radius. So now we know that we've got 1,200 cubic centimeters for the volume. So we're going to plug it into our formula. Volume divided by 30. So now it's r equals the square root of 1200 divided by 30, which gives us r equals the square root of 40. And the square root of 40, because it says estimate its radius, the square root of 40 is pretty darn close to the square root of 36. The square root of 36 is 6. So I would say that the answer to this problem is that the radius is approximately 6 centimeters. So that's your final answer for that one. Because 6 times 6 is 36, the square root of 40 is close. So that's all you need is close, because it is an estimate problem. All right, so name all sets of numbers to which the real number belongs. The first problem we have is 18 divided by 3. Remember, say that over and over in your head, that 18 divided by 3, 18 divided by 3, that's what that fraction bar means. Go ahead and do the work for it. The fact that you can write this as a fraction makes it a rational number automatically. So you know it's got to be rational. And remember my cute little saying about the quadfecta. You're looking for up to 4 different labels. We're looking for rational, integer, whole, and natural. Or irrational. So in this problem, we know it's a rational number because it is not repeating, it's not terminating, and, because it is a whole number. 18 divided by 3 is 6. And we know that it is an integer because it is a number on the number line, like 0, 1, 2, 3, 4, 5, 6. We also know it's a whole number. It's considered a whole number, meaning it's not negative. Although the integers can include negative, it's not negative. And it's a natural counting number. So this one is my quadfecta. So this is all 4 wrapped into one. Now let's go ahead and look at number 13. The square root of 35. Remember, an easy way to remember this is if you're working with square roots, unless that number underneath the radical is a perfect square, the answer is going to be irrational. It's going to be irrational because you're going to get some crazy long answer. So if you do the square root of 35 in your calculator, you get 5.91607, blah, 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 blah. It does not terminate. It does not repeat. So that means it is irrational. So not repeating, not terminating makes it an irrational number. Once you've determined that a number is irrational, there are no other questions to be asked. So at this stage in the game, if it's irrational, done. It's irrational. If it's rational, you need to go down the list in that order. Is it an integer? Is it a whole number? Is it a natural number? All right, great. Moving on. Now we need to order each set of numbers from least to greatest. So the first thing that you need to do is get all of the values into decimals. So actually the very first thing was to make sure that you notate that it was least to greatest. So on here it is least to greatest. I've already started by doing the square root of 2, which is about 1.4142 dot, 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 dot. So I always do the dot, dot, dot. That becomes important, and you'll see in this problem why. And then I made the number line. If you don't know how to make the number line just yet, you can hold off until you've converted them to decimals, and then you can make an appropriate number line. But it is important that you understand how to make it so that you know where to place things, the values on the number line. So we're going to place the square root of 2. Notice I used the original number, the square root of 2. I didn't use 1.4142. We're going to place that just after the 1.4. The reason we're going to do that is because 1.4 is actually 1.40. So if you think of that in terms of money, that's like having $1.40. Whereas if you think about square root of 2, it's got 1.41. That's like having $1.41. So you can see that it needs to be just right of the 1.4. The next number that you're looking at is going to be 140%, which literally means 140 per 100. Remember, you put it over 100, you divide 140 divided by 100, and you get 1.4. Now you can see that there's a difference. Notice 140% is going to go right there, right on the 1.4. So that's a huge difference for you as far as which one comes first and which one comes second, and it's only a very tiny difference in the actual value of the number. So now we're going to look at 1.45. That one was pretty easy. 1.45 is a pretty straightforward number. Now we're going to look at 1.4 with a repeating sign over it. Now notice I converted 1.4 with a repeating sign to 1.4444. I did that because there's a difference between 1.4 and 1.44. Notice that orange number that we're going to put here isn't anywhere near that pink one. So 1.44 would be just before the 1.45 mark. Okay? So now your final answer with the original numbers, make sure you're using the original numbers from the problem, not the converted ones, should be 140%, the square root of 2, 1.4 with the repeating sign, and 1.45. Hopefully that helped. And now we've got number 15 where you're comparing the numbers. If you can do 14, 15 should be a piece of cake because 15 you're just looking at two different numbers. So in the calculator we're going to do the square root of 15, which gives us about 3.872 blah blah blah. So now we're going to look and compare it to 3.9. Again, if you're not great with decimals and place value and understanding the value of the numbers in each digit, look at it as money. Look at those first few digits around the decimal as money. $3.90, $3.87. Oh, that means that 3.872 is less than 3.9. So we're going to put the less than sign there to make it correct. The next problem is the square root of 9.8 and 3.1 repeating. So the square root of 9.8 should be 3.1304. Please notice I did not stop at the 3.13. The reason I didn't stop is because the next part of the problem is going to be 3.1111. So it's very important that I know that extra 3 is in there. So now we're going to compare starting on the far left. 3 and the 3 is the same. 1 and the 1 is the same. Now we come to something that's different. That's a 3, that's a 1, so that means that the square root of 9.8 must be greater than 3.1 repeating. Number 17, write each fraction or mixed number as a decimal. So now you're going to have 9 divided by 20. Remember, I've said it over and over, 9 divided by 20. So now you're going to set it up as 9 divided by 20. If you can't remember which number goes where, then you can always think of the 9 as being a 2-story house. So 9 and 20, 2-story house, top floor, bottom floor. And the 9 is the one that has the roof over it. So when you draw that division sign, when you're actually doing the problem, the roof right there goes over the 9. So that makes sense because the roof goes over the second floor. So now, as you can see, you should anticipate that you're going to have to add 0, decimal, decimal, 0. The reason you anticipate that is because this is a traditional fraction. It's not an improper fraction. So since it is a traditional fraction, you know that the value has to be less than 1. So if you accidentally flip-flop the numbers 20 and 9, then you're going to start out with something like 2 point something. And that's just not the case because this is a value less than 1. That's the whole point of it being a fraction, is that it's a number less than 1. So now we're going to add the 0.0, 0, decimal, decimal, 0, and then from there we just divide. 4 times 20 is 80, subtract that out, we get 10, drop a 0 and add it, then we're at 100, and 5 times 20 is 100. So that leaves us with 0.45, which is our final answer for this. And just a little side lesson on here, 0.45, is that irrational or rational? That is very rational. 2 reasons. Number 1, it's set up as a fraction, so the fact that it can be displayed as a fraction makes it rational. And also, it's a terminating decimal, meaning it's not repeating in some funky order. You know that it's exactly 0.45. All right, the 2 problems that we're going to do now. So number 18 is 2.44, and we need to write that as a fraction or mixed number in simplest form. So please don't go through all the trouble of getting the fraction together and then not simplifying it. So the first one is 2.44. We're going to write that 2 kind of big off to the side because it's going to be a mixed number because it's got a whole number first. So 2 and 44 over 100. Then we do the lollipop method where we draw a little lollipop and a stick right there where the decimal is. And then we put zeros on any numbers that are to the right of the stick. So we're going to end up with 44 over 100. That is not yet simplified. So we need to divide both the top and the bottom by 4 so that we can get that number in simplest form, which is 11/25. I can't tell you how many times I've seen students be really excited, they got the answer, it's all good, they put 11/25 on the paper and they move on. Please don't make that error either. Make sure that you go back to the beginning of the problem and say, oh, this was 2.44, that means my answer needs to be 2 and 11/25 because it was a mixed number to begin with. Very good. Now let's look at 0.8 repeating. This process I'm going to give you right now is a lot easier than what I showed you in class. It's really, and it works every time, so we're going to do it the easy way. We're going to do 0.8 repeating. We're going to pretend like it's just 0.8 for now. Use the lollipop method to put it as 8 over 10. Instead of simplifying, we're going to first, because it's a repeating decimal, we're going to take the 10 that's on the bottom, and since it's repeating, we're going to subtract 1 from the bottom, from the denominator. So what that looks like is 10 minus 1 is 9. So then your final fraction in this one is going to be 8/9. So you'll see that right in a second. Subtract 1 from the denominator, 8/9. Do it in a calculator. Type in 8 divided by 9 and you'll get 0.888888888 forever and ever. All right, so that's way easier and it works for all of the repeating decimals. So we'll just go ahead and do it that way. Super duper easy. All right, so I want you to study and do well on your test tomorrow. I have confidence. Make sure that you review any of your past quizzes, any of the corrections that we did, and any of your lesson notes. Composition notebook, and definitely those scales. They'll help a lot. Thanks and have a good evening. Bye-bye.